Preface and motivation. The book opens with a discussion on the limitations of traditional series expansions in solving the three-body problem, noting that such series often fail to converge uniformly in practical cases. Hagihara follows the pioneering work of Henri Poincaré, who suggested that a more fruitful approach to these problems lies in the realm of topology and qualitative analysis. The aim is to investigate the existence of periodic solutions and understand the behavior of trajectories in a more general, topological context. Existence of solutions. This chapter deals with the mathematical foundations for the existence of solutions in the three-body problem. It begins by outlining the singularities of the differential equations governing motion, particularly at collisions between bodies. Key results include Sundman's transformation, which regularizes binary collisions, and the Weierstrass-Sundman theorem, which provides a rigorous framework for the analytic continuation of solutions beyond such events. The chapter also discusses the regularizability of triple collisions and describes the asymptotic behavior of solutions at infinity. It addresses complex phenomena such as hyperbolic, elliptic, and mixed motions, and introduces criteria to determine the nature of captures and escapes among the celestial bodies. Theory of characteristics. Poincaré's theory of characteristics forms the basis of this chapter. It explores the geometry of curves defined by differential equations, particularly around singular points like saddles, nodes, and focal points. The chapter provides a classification of singularities, along with tools such as Euler's polyhedral formula to generalize the distribution of these singularities. An important portion of this chapter deals with geodesics on surfaces of different curvatures, relating the motion of particles to these geodesic trajectories. The work of Hadamard and Morse is mentioned, which extended Poincaré's initial studies by introducing concepts like caustics and kinetic foci on positively curved surfaces. Topology of the manifolds of motion. This chapter shifts focus towards the topology of the manifolds that describe the possible states of motion. It builds upon earlier work by Poincaré and Morse to introduce variational principles such as the minimax method, which aids in finding periodic solutions. Additionally, the chapter introduces fundamental concepts in algebraic topology, such as homology, homotopy, Betti numbers, and torsion coefficients, which are used to analyze the topological structure of dynamical systems. The chapter concludes with an analysis of the restricted three-body problem, where one of the bodies is assumed to have negligible mass. This reduced problem is studied in detail using topological tools to explore the structure of its solution space. Surface transformations and invariant points. Building on the invariant point theorem of Poincaré, this chapter delves into Birkhoff's work on surface transformations. The classification of surface expansions near invariant points into elliptic, hyperbolic, and parabolic types is a key focus. Birkhoff's contributions to the existence of periodic solutions in various settings, including the restricted three-body problem and the billiard ball problem, are also highlighted. This chapter also addresses the ergodic theorem, extending the discussion to recurrent and non-wandering motions, and showing how these ideas contribute to our understanding of long-term behavior in dynamical systems. Conclusion. Yusuke Hagihara's volume on the topology of the three-body problem is a monumental work that integrates deep mathematical tools from topology, geometry, and dynamics to tackle the three-body problem. By moving beyond traditional methods and focusing on qualitative behavior, the book offers a rich framework for understanding the complex motions of celestial bodies. The work is foundational for anyone interested in celestial mechanics, particularly in the study of periodic and quasi-periodic solutions, and the topological structures that govern such motions.